Hello. Okay, I think no one has joined. We'll just wait. Hi, Rohi. Let's just wait for some time for others to join. Just a minute or two, maybe, then we can start.
Okay, okay.
I'm not sure, Rohi, if anyone else is going to join. Let me share screen and let's start. Okay, so I'll just share my screen. Please let me know if you are able to see it.
Yes.
So I've just executed all the cells. Let's wait for that to complete and then we can start. This is done, but why is this not printed? Okay, done. Fine. So until yesterday or until the last class, I think Saransh is trying to join. Good. So until the last class, what we have seen is that we were able to do some very basic data analysis onto pandas. However, there are far more. We are going to look into that, but for that we need the good background onto statistics as well, right? So which we have not covered yet. So let's see after or during when we cover statistics, we are going to again come back to these libraries like pandas and numpy and scipy. And then we also looked into the fact that we can do very basic data analysis with respect to visuals, right? So but then the visuals are like they are limited to a certain set. They are not extensible, so that is the reason why we will now continue. I'm not going to use this notebook. I'm going to use a different one, so I'll create a new notebook and we are going to look into some visualization libraries. We will be looking into some very basic plotting techniques, and then we'll move on to the rest. So I'll just name this as intro to visuals. Okay, and give it a okay. So for this, what we are going to do, we intend to use the same New York weather, let's say, data set. So it makes our life easy. So to import the data, I'm going to say import pandas as PD, and then I'm going to say PD weather is equal to PD dot read CSV, and then NYC weather dot CSV. Okay. Now I have the weather data. Let me check if I have the header data or not. Now I am not just for the sake of time or to save time, I'm actually not writing any comments or any headers and so on. But as I've already informed earlier, please don't do that. Please use as much as comments and as much as textual information as you can. Right? It's really going to help you. I can't stress enough on this point. Okay, so let me just create a few more. So I can see the data, but I don't have all the changes that I had done. So maybe I'll just quickly do a few things which we have already done in pandas, or maybe what I can do. Let me just close and hold this. Okay, and let me go back to this library and let me make a copy. Save, make a copy. I'm going to make a copy of this. I will save this and close this. And in that copy, let me import everything, because then what is going to happen is if I just execute weather.head, I don't think this is going to run. I may need to run it entirely, but the reason why close and halt. So 1 minute. The reason why I copied this is because interest visualization 01 custom CONTD. Okay, so the reason why I continued using this is because so that I get all the data analysis that I have already done. So let's just wait for 2 minutes and I'll run all the cells. This is going to quickly run, should not take much time. And then we can start from there because we have already done some kind of processing with the data, right? So I don't want to lose whatsoever work we have already done. So usually data visualization comes only after we have prepared the data, right? So visualization is a technique. A technique can only be applied once you have the data ready. So I have the data ready. Now I would like to do some visualization. So let's say that let's now try visualizing the data set using matplotlib and Seaborn. Okay, Seaborn libraries. So I'm going to tell you what these libraries are, where they are used, why we are going to use, let's say, matplotlib, and where we are going to, let's say, use Seaborn to get more understanding of the data. Okay, so I'm going to import the library. So import matplotlib pyplot as PLT. So matplotlib is the library. The one or the specific objects that we are going to use are part of the functions which is known as pyplot. So that's exactly what we are going to import. Rest is not really required for us when we are doing the data analysis. So we are not going to import the entire matplotlib library. We are importing only a subset of it. Then we have Seaborn. So import Seaborn as SNS. So PLT and SNS are like the generic industry standard names that we give. You can give any names you want. It doesn't really matter. Now, once this is loaded, we can use basic plotting functions, and then we'll come to know where matplotlib is useful, where Seaborn is going to be useful. So upfront, I can tell you matplotlib is where you just want to do some raw data analysis. You want good visualizations, and when I say good, I really mean that. Okay, visualizations which are of or at par scale of, let's say, softwares like ClickSense or Tableau, or let's say Power BI and all those visualization tools that we have seen. If that's what you're looking for, I would suggest go with Seaborn, because Matplotlib can give you, but only to a certain extent, not really much. Matplotlib is more, let's say, statistical or mathematical in its texture. But when it comes to Seaborn is like industry ready visualization. Okay, there are others as well. there is a JavaScript library also, which we can make use of in case of Python. But in that case, you'll have to write some code in JavaScript as well. That is known as data-driven something D3.js. So D3.js is one of a very popular kind of library, but that is there in a different area. That's like a dedicated software and tool. We are really not going to learn that right now because this is not the time. So what we are going to look at, let's start with some basic histograms. Okay, we are going to look at some basic histograms. So what I'm going to do, I'm going to write a few lines, which is not going to be a big functional contributing factor when it comes to plotting the data. So the only command I need to write to plot the data is call the alias plt, and then I'm going to say hist. Right, I did a tab and it printed a hist, and then I'm going to simply pass the column that I want to take a histogram on. Example given, I want to take a histogram on this. Okay, so this is the column on which I would like to take a histogram. So let me just put it over here. It should be able to give me the visualization. Okay, no questions asked, it gives me the visualization. Ideal condition, this is not what I'm going to do because there's a lot of output I see over here which I would like to avoid. And how I'm going to avoid, and then I'm going to beautify this, is that the basic things I apply is this plt dot figure. Okay, the first function I'm going to apply is plt dot figure. Plt dot figure is going to help me define what is going to be the size and the dimension of the figure. Inside this, the parameter I'm going to pass is fixed size, and fixed size will take a set of values. Okay, we have already seen sets, right? Unique, the values has to be unique. In this case, it can repeat as well. I can say the values can be 10, 10. Okay, and then at the end, I'm going to put another entry which is known as plt dot show. If I do this now, see what is going to happen. All the unnecessary clutter is gone, and I have a very clean output whose length, okay, the length is also 10. 10 is just an let's say an approximation of the height of this notebook, and 10 in width is also an approximation. So maybe I'll lower down this. I'll take 8,7. Okay, so it's going to show me a graph which I can visualize very easily, and I am able to see the data very well. Now, this is not exactly what I saw over here. There were grid lines earlier. Here, I don't have the grid line. So if I want grid lines, then yes, such kind of options can be enabled as well. Okay, so let's try to find out matplotlib pi plot grid lines. Okay, so we are going to look into a few of these kind of, let's say, techniques. Let's see what kind of is. So let's do this. I think and yeah, examples. I'll go to one example and I'll see where they have used grid. Grid is equal to true. This is what they're doing over here. Okay, so let me just do the same thing as well. So plt grid is true. Okay, now I can see it has also given me a grid. Now the thing that we have noticed over here is that I've used plt.grid over here. Why not after this? Let's take this from here and let's put it over here. Okay, I can put it at any place, right? But then you see what it is doing. It has printed the data first, and then it has printed another checker box kind of an area where it has done the grid. So you need to be very specific for which part you need to have the grid, and that is the reason why it is a flow of the program that whenever you are calling the actual functions, I'm going to comment this as the actual line of code to print the histogram. Okay, so when you're calling the actual line of code to print the histogram, before that you set all the parameters or the properties which you need for this histogram or this histogram output. At end of the day, this is optional actually. You may want to skip this, but then if I skip this, this is what is going to happen. It's going to give me some metadata information about the plot as well, right? But that's not what I want. I want a very clean kind of a graph. I just want to line some lines of code. It should be able to give me good amount of graph. Okay, now there are other things as well that I can change. Example given, matplotlib pyplot color. Okay, so if I look at, let's say, color, I can clearly see that there are certain, let's say, parameters which I can clearly see in this example. Let me just copy this over here. Okay, and I'm just going to use this inside this. Okay, so it is use something like this. So color, I will say red. Okay, line style and all these things I'm not going to use because this is not really required for me. So I'll just remove them and I'm going to print it like this. So as you can see, you can also play around with the colors. Okay, so this is one way in which I plot. Now there are many other plots that I can do. Example given plt dot. If I just do a tab, I have done a tab. It is taking some time to load. So if I do a tab, it is going to print me all the functions which are there in this library. Okay. Now, as you can see on the screen, there are a lot of functions that I can use, but I'm not going to use all the functions. I'm going to show you few of the functions which are really, really useful when it comes to the data analysis part, because this is not where we are going to learn about all the functions available to do visualization, right? We need to do some visualization basis, some kind of objective which we have in mind. So if I am visualizing this weather dot wind dir degrees data, the reason why I'm doing that is because I want to show you there is a small concentration of entities on the lower side of the data range, while everything else in the month of January 2016, for which this weather data was collected in New York City, everything is actually pertaining to the higher side of things, right? So that's my objective. That's what I want to convey. So my visualization. So this is a very, very interesting point which you can also remember. Any visualization technique you choose should be driven by some kind of intuition that you want to show to your customers. Okay, don't use all the visualization technique just for fun. You're not doing this for fun. You're trying to look into this visualization, trying to get some idea about the data, trying to upfront answer questions. Now this data set is really too dummy to answer any questions, right? I know this is kind of an imposition right now, but then we are going to look into data sets which are like hello world use cases of, let's say, machine learning. And in those cases, it is, I mean, 80% of my problems will only be resolved if have done good and upfront visualizations for the questions I want to answer. Okay, and that's exactly what I would like to try now as well. Example given, I told you in one of the previous class only, I think we looked into the standard deviation, right? So in this case, as you can see in these three columns, temperature, dew point, and humidity, the standard deviation is at least comparatively more than that in the rest of the columns, while in wind direction degrees also the standard deviation is very high. And that's why we use this kind of a plotting technique yeah, to look into the variation or the distribution of the data. Why not? Let's copy paste this code and let's try to change this hist. Okay, I'm going to change this hist and I'm going to look into something else. I'm going to look into what is known as BOXPLOT or box plot. Okay, so why I am looking at a box plot is this. You see, this is going to actually tell me what exactly are outliers and where they really reside, if at all they reside. But it does not tell me whether the outliers are genuine or not. This is the point we have briefly touched in the last class as well. I'm going to discuss this here as well. So here what you see is an output, and in that output you see a box. I would strongly recommend when you're looking at this kind of things, right, you should first of all not use grid and then you should use grid. So let's first of all do it without the grid. Without the grid, I can see a very clean output. Let me reduce this as well. Why not hash this? Okay. And I can see this is a small output just to fit in the screen. I did it small. Now what I can see, this box over here, right, the one that you see, I'm going to take a pen. This box over here that you see is the actual spread of the data. This is where the data lies. Okay, or majority of the data lies. This small line which you see over here and this line which you see over here, this one represents the mean. Okay, this is the minimum and this is the maximum. Okay, this is the mean value and the maximum value. Then what are there in these three boxes or inside these boxes? This orange line you see over here, right? This one is your average. This is your mean. Okay, this is the mean. Or you can also say that this is 50% of your data. Okay, anything which is mean falls within the 50% range, right? So that's the 50% of your data. This is the 25% of your data, and this line, the upper edge of the rectangle, is the 75% of the data. Okay, let's try to verify this. Okay, we are going to delete this. You understood, right? So this line here is max, the top line. The lower line here is mean. Then there is a box. Inside that box, the box looks something like this. Inside this box, this is the upper edge, this is the lower edge, right, of the box. The lower edge represents 25% range, upper edge represents the 75% inclusion, and then there is some line going through in between. This represents the mean or the average of the data, or also the 50% range of the data. So let's try to understand if this is really the case. Let me clear all the drawings and close this. And now I'm going to extend the grid. So approximately, let me also put the figure thing as well, so that I can clearly see. Now let's go back to the data, or maybe I can do it here only. Why do I need to go back to the data? I'll take this and I will do this. Not sure if I told you about this. You can take a single variable and do a describe as well. It is not necessary that you need to do it on the entire data frame. We did it so that we get all the output at the same time at one go. Okay, that's the only objective. Now, what is the mean? 34. Okay, is that really represented here? The answer is no. This line should have represented the minimum, but it is not representing the minimum. This line over here, you see it is somewhere near 240. Do we see anything near to 240 over here? The answer is yes, 25%. Okay, 25% bracket is represented somewhere over here, and then there is a whisker. This extension, right, is known as the whisker. You see, the minimum value here is 34. So 34 is not the lower whisker. The lower whisker, I expected it to be 34, but that is not the case here. Why is that not the case? Is the interesting thing that we are going to look into. Max is what? 345. Is max here? Yes. See, this line is actually representing the max, and the max is actually representing 345 because it is closer to 350. You see, this line is going to converge over here, right? So it's representing 345. Then what about the upper bound of this thing? So it is representing the 75%, right? So 300, exactly matching. This one is the 50%, so it is close to, let's say, 280 or something. Is that the case? The answer is yes. Then the 25% range is like 238. Is that the case over here? The answer is yes. You can see if you draw a line over here, approximately it is equal to 238. And then the lower whisker is approximately at 235. I don't have anything here which is known as 235. Then why is it showing this? And then this 50% should actually come closer to the mean value as well, right? But it is not. So the reason why it is not coming here is because you have a very high standard deviation. And this is an upfront example where a visualization can quickly tell you that there is a problem with the data, or there are presence of outliers in the data. Now, presence of outliers is not a problem. It is really not a problem. There can be outliers. As I told you, if I'm going to take a salary distribution of all the employees in the department where I'm working, obviously I'm going to include the department head as well, because ultimately he's also an employee. But then if you look at the range of salary that we guys have as compared to the salary of the department head in our case, then that will be a huge kind of a difference, right? That is the reason why you have entities which are represented as small circles over here. So these are your outliers. These do not fall within the box. These do not fall within the whiskers of the box. Okay, this is also known as a whisker plot. This does not, these 6 or 7 points, I can clearly see there are 1, 2, 3, 4, 5, 6 points. These 6 points do not fall within the scope of this box, and that's why they are, in this case at least, potential outliers. They are outside the range of the normal set of the data that we have. And that is why the minimum value is set by an outlier, and that's why it is not showcased over here. So ideal condition, a box plot, this line is always going to show you the minimal value, but in the presence of an outlier, it's not going to show you the minimal value. Okay, if you would like to know more about this, I would like to suggest this. You can come over here and you can look at some diagrams. Let me just look at a few diagrams. You will come to know what is going on over here. Okay, so this is what is actually going on over here. You see, there is a minimum, there is a maximum, right? So minimum and maximum is now represented into a different way. I'm not going to explain this function right now, or what is an IQR. IQR I'm going to tell you at a later stage, but you can as of now imagine that this is the difference between the first and the third. Okay, so if you take a range of what is the difference between 25th percentile and 75th percentile, that is the difference between the range of values between 25% of the data and 75% of spread of the data. That's otherwise known as an interquartile range. We are going to look into this in depth when we go into statistics. Yeah, don't get confused right now. But now, because we saw that there can be outliers in the data, right? That is the reason why this definition is now going to tell us. Let me just expand this. This definition is actually telling us now that let's not consider the minimum and maximum as the whiskers. So we are not going to consider the whisker or these bars which are at the end of the box plots as the value or the data values which are minimum of the data or the maximum of the data, right? What instead we are going to consider is that they are part of an interquartile range determined by the fact that this is Q3 or quartile 3 or the 75% range of the data. The 25 to 75% of the data falls within this box. Anything which is 1.5 times more than the 75th percentile is the maximum. So this line over here represents the value which is actually the range. It is representing a cutoff which is 1.5 times the value of Q3, and this value is representing 1.5 times the value of this. Okay, so exactly here you can see the interquartile range 1.5 times. If I minus from Q1, it gives me the minima, and if I add interquartile range with 1.5 or the 1.5 times of the interquartile range with the Q3 or the 75th percentile, it's going to give me the maxima. Anything which is falling outside the minima and the maxima is otherwise known as outliers. As simple as that sounds. That is why the current implementation of the libraries implement things in this order. Okay, so that is how it is actually implemented here. Okay, now what we are doing here is, give me 1 minute. Okay, now in this case we have outliers. Let's see if that is the same case when it comes to any other column. So I'm just going to override this, right? We have already seen this. So let's override this and let's try to look at some other column, maybe this one which we have already seen earlier, weather dot temperature. Can we use weather dot temperature over here? I'm sure we can, because it is a numeric thing. Right now, if I plot a box plot of this, look how good it is. Look how good the box plot is. Because of the grid as well, it is looking quite good. The median value or the 50th percentile value exactly lies almost at the middle of the graph. You see, from 20 to 50 is the range. The interquartile range falls between 28 until 39 approximately, and this top whisker or the maxima is at 50, the minima is at 20. Let's try to see what is happening over here. If I take a describe of this, because it does not have any outliers, you see the minima or 1.5 times IQR when subtracted from Q1, right? So 1.5 times IQR subtracted from Q1. Q1 is the 25th percentile. This should ideally match with the minimum value. You see, it is exactly matching. This is exactly equal to 20. You see, it is falling exactly on this line. Why is this? Because there are no outliers. Had it been the case there are outliers, this would never be the case. This is the scenario here. This line is going to misguide you if there are outliers. That is the reason why in statistical analysis everybody is scared of having outliers. Okay, now okay, so let's come down and see if all of our rest of the assumptions are also matching here as well. See, maximum value is also matching with max. Had it been the case there were outliers beyond the max, this value would have come down. This graph would have squeezed. Okay, this upper maximum would have squeezed down and all the outliers would have come over here. Okay, but that is not the case here. 75th percentile is like 39.5 clearly represented. Then we have 50% over here, which is the 35 value. This is also known as the median value. I will quickly come back to median. I believe we touched based on mean and median quickly earlier, but I'm going to quickly tell you what this median is. Okay, then we have this lower bound or this lower minima, or otherwise known as this Q1 or 25th percentile. If this is 25th percentile, this value is, let's say, approximately 28 or 29, and that is exactly what we see over here in the output of the describe as well, right? So we can clearly see this is what the case is. But now let's don't get confused with the value of the standard deviation here. I have already told you this is not a representative of the data, right? So because this is not representative of the data, you can clearly see this interquartile range has nothing to do with the standard deviation, or you are not able to find any relationship between the median and the upper bound or the lower bound, or Q1 or Q3 over here, right? So that's really not the case. This is just a measure. This is just a number which is showing you the kind of problems you may have within the spread, right? So this is one thing. Let's look into the other things. So to do that, let me just do a head and see what other columns we have, or maybe I will also do info because I forgot this data set. Let me just do an info as well, and let's see what other plots we can do. So we have any categorical variables over here? The answer is no. Okay, maybe this one is a categorical variable because I somehow feel that cloud cover is going to be a categorical variable, but it might not be. It is just my assumption, right? So precipitation is also quite disturbing. It will be because there were many values which were marked with T and all these things, right? So we have converted that into uh, other things. So what I can try to do is that let's look into some other kind of plotting. Let's say I would like to look at a plot which is like a comparison of temperature by humidity. Okay. So I would like to see if there is any relationship between temperature and humidity. If the temperature increase, does the humidity increase or decrease? Upfront, it is really very difficult for me to tell. So let's see if there is any technique which is available in the visualization libraries as well. So let me just copy the code. I'll just keep this info and this head output over here. Later on, you can remove it from your site. Yes. What I'm going to look at right now is otherwise known as a scatter plot. Okay, when I draw this, you are going to come to know what this means and what this is going to result into. Okay, I'm not going to tell about this right now. We are going to look at the output and then we are going to comment. Okay, so if I do something like this, I don't think I've used the right function. It should only be scatter. Yes, I have created a scatter plot. What this scatter means is that what is the value of x and y axis. Now, the first thing is what is the scatter or the dispersion, you can say, in a visual format, not in case of a statistical format. In terms of, let's say, statistics, dispersion has a different meaning altogether. Now, in this case, I am trying to look at a relationship, but I'm not able to understand. Then I'm also not able to understand what is this x-axis and y-axis. Now, in scatter plot, I always take two variables. Okay, the first one becomes my x-axis. So this is my x-axis, but it is not represented here properly. So let me just do that. I'm going to use a function called x-label, and I'm going to say the label for x-axis. I'm sorry, x-axis is the temperature. So this one is the temperature. Okay, so x-axis is going to be temperature, and plt.y label, the label of y-axis, is going to be humidity. Okay, I only have 10 minutes left. Fine. So now, if I do this, what is going to happen is it's going to give me the names now. So I can clearly see what is happening here. Also, let me just get rid of this figure thing and let me add another very important thing, which is plt.title, and I'm going to say relation is temperature and humidity related. So that's what I'm trying to find out, right? Visually, I'm trying to find out if there is any relationship between these two. So let me just write a small comment over here as well. Let's further try to understand if there is any relationship at all between uh, temperature on a certain day as compared to the humidity on the same day. Okay. Now I am going to run this now, and it's going to be a smaller diagram. Now it is saying, is temperature and humidity related? The answer is, well, I can't say. I can see that there is, let's say, kind of a line which is going somewhere like this. This is a very bad line. Some line which is going here and then here and then here, right? So there's some kind of an upward trend. I can see that if the temperature, let's say, is increasing, uh, the humidity may also increase as well. But I don't know, because I can't really say that. There are cases which are actually confusing me. There are cases like these. There are cases like this. So there is not really a very good relationship, right? There is also cases like this, and these are like the extreme ones, right? These are like extremely away from the expected line, or the line that I have drawn, where majority of the points are closer to this. You see, majority of the points are closer to this line, but everything else, at least 2, 4, 5, 6, 7, 8, 11, 12, 12 points are away. Okay, out of 31 points, 12 points are away from the expected, or the assumed or visual relationship which we see between temperature. I can't really comment if there is any relationship. There is no upward trend or there is no downward trend. So I can try to do similar things with all of the other variables, and then I can try to see if there is any way to look into the relationship. Now, how I can do that is this. I will just quickly go through this because we still have, yeah, yes, we have 7 minutes left. So what I'm going to do, let's do one thing. Oh man, what I'm doing? Why is this getting code markdown? Yeah. So let's check similar relationship for all variables. Okay. So what I can do is that, taking list of all columns, okay, loop through and show the visualization. Okay, this is a very common technique which I use. I have seldom seen anybody use, but I do use. So for each column in weather is my data set, weather dot columns, I would like to do this. Now this is going to be very tricky, because I would like to compare the temperature with everyone else. Okay, so let's see if I can do that. Okay, let's see if I can do that. Okay, I'm going to paste it over here. Okay, XY label is going to be each column. Let's see if this is going to work. Is temperature, I can't have a title. I can't really have a title. Uh, I will have to do something else. I will have to do something like this. Print is temperature related to comma each column. As of now, maybe I'll even choose to, if each column is not equal to EST. Okay, then only I will do this. Okay, so I'm not taking that in Eastern Standard Time. I'm just trying to compare the rest. Okay, now what I have to do over here is that I have to use a bracket, and inside that bracket I'm going to say each column. Okay, and then I'm going to do a plt.show, and then let's see if this is going to result. Not equal to is not like this. Okay, sorry. So it should result into a series of graphs. So what I am doing, temperature, is that related to temperature, or each column is not equal to temperature. Okay, I don't want to compare the temperature with temperature, right? I know it is going to be a linear kind of relationship. Now it is trying to print everything, and I can see the relationships between each and every variable as opposed to the temperature. This is really useful. It gives me a lot of information, but there is something that I would like to solve. Okay, first of all, is temperature not equal to EST, then why is it coming over here? I don't know. There's some bug in my code. It shouldn't have printed this, right? Why is it taking EST? uh, not in. uh, I will have to fix this somehow, maybe using a list. Okay, or temperature not equal to temperature. Yes, this should have worked, but I don't know why it is taking EST as well, but that's fine. Let's not complicate our lives over here. Let's remove this. Okay, and we can print this. Okay, so this is what is being printed over here. Each and every column is getting compared with the temperature. Let's say the date over a period of time. This is actually an ulta diagram. We should have printed temperature here and date over here. We are going to do that. So we can see I think really obvious over here, because everything falls within this kind of a range. Obviously it is going to fall within this range because our x and y axis is actually different. So let me just change this to EST temperature. We're going to handle later. So temperature related to temperature, obviously it's going to be uh, uh, a linear kind of a relationship, right? So this is like a dot matrix or something. Then we have this temperature related to dew point. Now you see what is happening over here. Temperature to dew point, this is a very linear kind of a relationship. Okay, this kind of a relationship is known as linear. As the temperature increases, dew point increases. Yes, there are a few outliers, but then you can clearly ignore these three outliers. Only three are the outliers. Rest 28 points are converging to a very simple linear line. So only by looking at this visualization, you see how many types and kinds of answers are we able to get. Is that in this case, I know at least for the month of January 2016, which is a sample that I've taken for the New York City weather, it is quite clear to me, quite obvious to me. If the temperature increases, the dew point is also going to increase. I don't know whether this is similarly the case for the entire year of data. I only have a sample representation of the data for 1 month. And here is what I can see. Is that the same thing with the rest? Let me see for the rest. Temperature to humidity, we have already seen this, right? Temperature to sea level pressure, in not really any good relationship. Maybe if we try to change the axis, maybe we can find something. We will note that this down and we will do this in the next class. Same applies to visibility miles. And if temperature has really no relationship between this kind of thing, but there is one thing that I can see. I can try to distinguish between the visibility miles. Example given, visibility in miles is really less, like 2 or below 2 and equal to 4, if the temperature is either very low or very high. So in case the temperature is quite low and quite high, the visibility of miles is really decreasing, while if for any other case, the temperature is like onto the edge. But I can't say that because there are outliers in this data as well. You see, there are 2 points where the temperature is quite less, but then the visibility miles is also very high. I don't know how this data is really calculated. Maybe this column has to be box plotted to see if there are any outliers, because this data is not making much sense to me. So in this way, we have started using the data analysis kind of principles, and we are trying to see if we can have visualizations by means of which we can look into such kind of aspects, right? So let's close this meeting as of now. We don't have time as well. If you have any queries, maybe we can discuss on our group. Okay. Okay, let's make an end, and we are going to discuss later on our group as well. Thank you so much. Good night.